So remember that we were trying to prove that for every positive integer n, 1 squared plus 2 squared plus n squared equals n plus 1, 2n plus 1 over 6. And in our last video, we wrote the outline for this proof, so now we're going to write the formal proof. We proceed by induction. We'll say for n equals 1, 1 squared equals 1 times 1 plus 1, 2 plus 1 over 6 is true. Now, assume 1 squared plus 2 squared plus k squared equals k plus 1. Let's fit it in. K plus 1, 2k plus 1 over 6 for some positive integer k. Then 1 squared plus 2 squared plus k squared plus k plus 1 squared equals, so repeat our computation from before, k plus 1, 2k plus 1 over 6 equals, plus k plus 1 squared. Get a common denominator. That was our next step. Factor out a k plus 1 over 6. And we're left with k, 2k plus 1 plus 6, k plus 1. Distribute and collect up like terms. You get 2k squared plus 7k plus 6, which then we factored into k plus 2 and a 2k plus 3. So therefore 1 squared plus 2 squared all the way up through k plus 1 squared equals k plus 1, k plus 2, 2 times k plus 1 plus 1 over 6. And that completes our induction proof. That completes our inductive step, which completes our induction proof.